What's up, everybody? This is page 364. We're starting a new activity in our book. This is on interior angles of a circle, and we're going to work through the theorem for our example today. Please highlight the habits of mind, reason abstractly and quantitatively. We're going to construct viable arguments and critique the reasoning of others. In this example on this page, we are talking about how the vertex of an angle can either be inside a circle, outside a circle, or it can actually be on the circle. And we've done the on the circle with our vocabulary word for inscribed angles. And we've done our inside a circle with central angle. And so for us, what we're going to do is continue adding, like, what if we don't have an inscribed angle? What if we don't have a central angle? What else is left for us to talk about? Okay, so consider a triangle, or consider the angle, right? Here, let me get my see the screen a little bit better. So in this circle, we have an angle BED. Highlight it. Add some sort of like information to what's here. We're creating chords AD and BC as shown. All right, there it is. How is this angle different from the other angles? Like I said, the central angle and the inscribed angle. What's the difference? I mean, honestly, it really just comes down to the fact that the vertex is not on the center and not on the circle itself, but it's somewhere in the middle of our circle space. All right, point E, maybe a better word than point would be vertex is not on the center, or I'll say edge of the circle. And that's going to create some new math for us to talk about. Also, this angle, point E, it's not creating like that same, like it is on the inside of the circle. So we're going to have some of those relationships that we've been talking about. What can you do with the interior of a circle? All right, can you determine the measure of angle BED with the information you have so far? Ultimately, no. Right. What we have right here needs some modification, and we're going to have to draw what we call an auxiliary line, so have something else, add some color to what we're using to respond here. So not really, or not quite. We're going to have to use information that we've been building from previous pages, right? And then in building that information, we'll use that to help create the angle that's missing. Draw the chord CD, all right? So I'm going to go ahead and line up my protractor. I'm going to line it up like this. I'm going to put a line across the space here. This is an auxiliary line that we have to add after the fact. And when we do that, right, we actually end up creating this triangle here on the inside. So let me highlight and pop out the triangle that we need to know, right? We are able to figure out the angles of that triangle because angle C is actually on the edge of the circle and it intercepts an arc. So we're allowed to say we have an inscribed angle. We also have this information. We have that BD is 70. So let's put a 70 out there. Now, if you've been doing your Mathia and you have been practicing your math book and the homework assignments and everything, you should be able to remember the relationship between 70 degrees and this angle. It's half, right? 70 and half. Inscribed angles are half of the intercepted arc. So that's one angle we know right now. We know the measure of angle ECD, middle letter, ECD, is going to be half of 70. There it is. Now, for the same reasons, maybe a different highlight color is necessary. AC right here, AC is 110 because that's what's told to us in the given information. So if we know that AC is actually an arc with 110 degrees, then EDC, this one, is going to be half of 110. So I can say the measure of angle EDC is half of 110, which is 55. Little highlight action. I want to see how things line up, right? So this was relevant to the green highlight, and this was relevant to the orange highlight. Let me check my notes. Yep, that's what I thought. It's the whole idea of the intercepted arc theorem, right? If I've got it as one of our vocab words. So then, therefore, another thing that we've talked about in this topic if you have the triangle drawn like this angle out here is actually an exterior angle of that triangle. And one of our theorems says that the exterior angle of a triangle is actually the same as what you get from adding these two angles. We have that as one of our learning targets, our goals for this module. So I can therefore answer the next question. How does angle BED relate to angle CED? Here's BED, here's CED. Together they form a linear pair. And if they form a linear pair, that makes them supplementary. So then, therefore, they are supplementary angles that add up to an 80. Okay, we're going to write a statement to show the relationship between angle BED and EDC and ECD. And it's really what we already did when we had the exterior angles of a triangle theorem. So I'm going to say the measure of angle BED equals the measure of angle EDC plus the measure of angle ECD. Some highlight colors just to remind you. EDC was orange and ECD was green. By adding those two angles together, we're able to say how big the angle we don't know is. It's not 55, it's not 35, but it's something between. It's got to be a little bit like around the 70 mark. Okay, so since we know that EDC is 35 and we know that EDC is 55, that means we can just add them together, right? I can put a 55 right there for 55 degrees. That's how big that angle is. That's actually able to be put onto the shape. This is a 55-degree angle. And then ECD, this one, the green one, which is across from the 70-degree intercepted arc, is 35. So then I can go back up to here in my answer for E/F, and I can add those two numbers together. 55 plus 35, 90. The measure of angle BED is 90 degrees. Okay, so last one. Describe the measure of angle BED in terms of the arc intercepted by BED and the arc intercepted by the vertical angle of BED. It looks like this. If we added these two angles together, these two intercepted arcs together, right? We're adding these two intercepted arcs together. 110 plus 70 makes 180. But the angle that's created here is half of that. So there's still an intercepted arc is an inscribed angle is half of an intercepted arc. We just have to consider both of the intercepted arcs based upon the angle measure. So that's what I'm going to put right here, all right? So let me see if I can get the screen where I need it to be. So the intercepted, the sum, there it is. The sum of the intercepted arcs. So we're adding, right? There's that sum means adding. The sum of the intercepted arcs. And these are the arcs that we're talking about. We're talking about BC and we're talking, or AC, I mean, and BD, right? We're talking about the arc. This was arc for AC, and this was the arc for BD. We're adding those numbers together. The sum of the intercepted arcs for the vertical angles is divided by 2. That's the relationship we're going to continue to explore in this lesson. Thank you for checking this video out. Please click forward on page 365. Wow, a whole year's worth of pages of lessons that we've gone through. Continue learning in your journey, and I will see you in the next video. Thanks.